Right into our inverse trig. So we're going to have a few formulas we're going to need to memorize for our derivatives. And let's see how we go get them. So if we were to have y is equal to inverse sine of x, also known as maybe y is equal to arc sine of x. Same thing, when you write the arc in front, it's saying the same thing as the inverse. It's talking about the arc, the radians, the block. Never mind, let's go. So y is equal to sine inverse of x. Now, if we could take a derivative on this, we just do it right now. So we're going to play a little bit of a game. We're going to say that these two things are equivalent. I'm going to draw something else. I'm going to say that if you were to take this, you were to take sine of y and say that it's equal to x, that these two things are equivalent under some circumstances. All we've done is swap the inputs with our outputs. It'd be like doing one of these, a sine on this side and a sine on this side, and that ravels everything, just leaves x and gives you the sine of y. That's just what's happening. Hitting at the outside. So we're saying that these two things are equivalent, but only under certain conditions. Now, inverses are angles, so y is an angle. So we're going to talk about our y value. Our y value can only be, because sine inverse is defined in the first and the fourth quadrant, our y value can only be between negative pi over 2 and pi over 2. That angle that we're going to be messing around with, okay? Just to make that little caveat as we do the proof, as something a little bit later is going to pop out. So let's go. Now this we can take a derivative on, but we had to wait until we learned implicit differentiation because that y is in the sign. Okay, cool. So let's take a derivative on both sides of this one over here. We're like, it's the same thing as long as we're in the first or the fourth quadrant. So let's go. We take a derivative on sine, and we're going to get cosine of y. And then, oh, no, we got to multiply by that dy dx. And the derivative of x is equal to 1. Let's go. So we want to solve for dy dx, so that means we're going to divide out that cosine of y. We're going to divide out that cosine of y. We can say that dy dx is equal to 1 over cosine of y. And let's not write this as secant. Let's leave this how it says. So shoot. We got a derivative, and it's cool, but man, we're trying to find a derivative on y with respect to x, and we ended up taking a derivative on y with respect to x, and we got freaking y in there. We got to change that y to an x. So we got to find some fancy way. And there's two methods. There's two different, well, they're all the same method, but they're hidden a little bit. We know this. We know that x is equal to sine of y. So if there could be some way that we could get cosine of y in terms of sine, we might be able to do something here. So let's jump aside and go. All right. Sine squared of y plus cosine squared of y is equal to 1. We all know that. Well, let's solve for cosine. So we're going to subtract out the sine squared. And now we're going to hit it with a square root, but we're like, but Mike, you said you need to use you got to use that plus or minus. Yeah, you do. You do. Unless you know for sure it's always freaking positive. Sine inverse is only defined in the first and the fourth quadrant between negative pi over 2 up to pi over 2. Did you know that cosine is positive in both the first and the fourth quadrant? Because cosine goes with x values, and it's negative over in here where the x values are negative. So we can say that this thing's freaking positive because of where it lies. We don't need to worry about the plus or the minus. Now we're like, well, cosine of y is just equal to the square root of 1 minus sine squared, but we already know what the frick sine of y equals. Sine of y is equal to x, so we just pop that x on in there, and we're like, there it is. We can replace with the square root of 1 minus x squared for our cosine. And here is our solution, 1 over the square root of 1 minus x squared. Therefore, the derivative on y with respect to x of sine inverse of x is 1 over the square root of 1 minus x squared. There's our first one. Now, we could have solved this in a different way. We could have solved this in a different way. If you don't like the Pythagorean theorem, we could have done this differently. Once we get down to this point, we're always going to need to sub in for cosine. So I did this method by using the sine squared. You could also do this method by trying to solve for cosine of y. So y is the angle. So make a triangle with y as the angle. Sine represents the opposite the opposite over the hypotenuse. Well, let's just go solve that triangle for the adjacent, and we can just solve for cosine of y. So we get a squared plus x squared is equal to 1 squared. So a squared is equal to 1 minus x squared. A is equal to the square root of 1 minus x squared. A has to be positive. Look at it, it's on the positive x-axis. So now we can go and replace it in. Go that way. So, dude, maybe you like making a triangle. Maybe you like using the Pythagorean theorem. I don't know you. I don't know what you prefer. So this is how we go through and show it. I'm going to do a quick one with tangent, and then I'll just give you the rest. Actually, let's go tangent. So let's say y is equal to tangent inverse of x. And we want to go find its derivative. So we're going to be like, well, this is the equivalent of tangent of y is equal to x, right? We're not inverse, so we say tangent of y is equal to x. And again, there's a caveat here. That y value needs to be between pi over 2, negative pi over 2 and pi over 2, and it can't be the endpoints. So first and fourth quadrant one more time, okay? First and fourth quadrant, where signs and secants are positive there. All right, so we're going to take a derivative on this. That's what we chose because we know how to do implicit. So we take a derivative on tangent and we get secant squared. We leave that y there, and now we take a derivative on y with respect to x. Derivative of x is equal to 1. Again, we're going to divide out our secant squared. It's the same game each and every time. I wonder if I'll put this on your test. I'm not sure. I'm not sure yet. And we get 1 over secant squared of y. Now this one's one of the simpler ones. So we always have to use this as our key to be able to put an x in here and change them from y's to x's. Whatever that first thing you dick around with, that's what you're going to use to, you're going to have to make that secant squared equal something with tangents in it. But, dude, come on, dude. Tangent squared of x plus 1 is equal to secant squared of x. That's a Pythagorean identities. You should know these on lock. Secant, oh, so let me change this to y's now. Oh, secant squared of y is just equal to tangent squared plus 1. So let's change that. So we change that into, we're like, well, tangent squared of y plus 1, but tangent of y is equal to x. So we can just replace that and say it's 1 over x squared plus 1. And there's your derivative on y with respect to x. It's 1 over, and I'm going to write it like this. Sorry, backwards. I'm just used to writing it that way. And there's the derivative of inverse tangent. Well, let's write them all up. I've done the proof, so we have the derivative. Jump into there. The derivative of sine inverse of x is equal to 1 over the square root of 1 minus x squared. All right, done with that one. Now we're going to go into the derivative of cosine inverse of x, and that's equal to negative 1 over the square root of 1 minus x squared. Very similar. We'd already found the derivative on inverse tangent. The derivative of inverse tangent of x is going to be 1 over 1 plus x squared. Now we're going to move into our reciprocal functions. And here we go. So the derivative, and now there's some ambiguity here as to how you write it. Our textbook actually writes that the answer is just this, equal to negative 1 over x times the square root of x squared minus 1. And that's just what our textbook gives us. Now you might find it in other texts or online with this written as the absolute value of x. No. Well, just know there might be a little bit of ambiguity here. And finally, we have the derivative on x of that. Now, this one might be a little bit weird for you. You might be like, what on earth? How could this possibly be? And it's actually just negative 1 over 1 plus x squared. So I don't know if you've seen that sine inverse is answered and cosine inverse are the same thing, just different signs. Tangent inverse and cotangent inverse are the same thing, just different signs. And you know what we're doing? Secant and cosecant are the same derivatives, just different signs. So, got to get memorized one way or another. Find those patterns in it, and I'll see you in the next. We'll start messing around.